Hello and welcome to Math 200 Online Statistics at Cañada College. My name is Lapuz. In this video, we will do a homework problem from section 7.2. They want us to use the sample data and confidence level given below to answer parts A through D. We probably want to find confidence intervals. A research poll institute asked respondents if they felt vulnerable to identity theft. In the poll, N, the total number, is equal to 932, and X, the number who said yes, was 589. They want us to use a 90% confidence level. I have all the data set up here in the Google Sheets form. We have our X value and our N value, and we also have our confidence level. This is the formula that's found in the book, so we will go ahead and use that formula. Our P hat is given by X over N, so let us just say equals, and then I'll click on the X value divided by the N value. So it looks like our P hat is about 63%, 0.6319. The Q hat is the complement of P hat. So I will say equals 1 minus, and I'll click on the P hat cell and hit enter. Now Z sub alpha over 2 is a critical value found from our standard normal distribution. We essentially want to take this 90%, which is in the middle, subtract it from 1, where we would get the tail. So we would have 1 minus the confidence level. And then we would divide that by 2, because we're only dealing with one tail. Now this number that you get here is going to be the area on the left side, and the 0, 1 is the mean and standard deviation. But notice that that area on the left side is going to be negative because it's on the left side of 0. And we want our critical value to be positive. Let's go ahead and type this command or this function. Norm INV 1 minus our critical value or confidence level is this number over here. Notice that this is in percent form, so it's actually 0.9. Close the parentheses, so let's divide that by 2. Our mean is 0, our standard deviation is 1. Notice that our value is negative, so to make that positive, let's just say equals, and then the negative of a negative is a positive. So it's the negative of that, which is going to be a positive. Margin of error has its own formula, but we have found the critical value, Z sub alpha over 2. We have P hat and Q hat, and we have our value for N. Let's go ahead and type that in. Equals Z sub alpha over 2. And we multiply this by the square root. We have to type SQRT, and then inside of the square root we have a P hat times a Q hat divided by N. Close the parentheses. And we have a margin of error of 0.02592598. Now to build our confidence interval, we will take our P hat and subtract the margin of error, and then we'll take the P hat and add the margin of error. For the left side, we'll say equals, click on the P hat cell, minus the margin of error. Similarly, equals P hat plus the margin of error. And we have all the values that we need to answer these questions. Questions A through D. Let's start with the first one. The best point estimate for the population proportion P is going to be the p hat value, x over n. We have that already at 0.6319, rounded off to 3 decimal places is 0.63, and the 19 becomes a 2. So we have our point estimate. Value of the margin of error, we have done the computation, and that is 0.0259, rounded to 3 decimal places, is 0.026. Next, the actual confidence interval. We'll start with the left endpoint, rounded off to 3 decimal places, is 0.6059, so that's 606. And our upper is 0.6579, so that rounds off to 8. Finally, we got a follow-up question, and they want us to write the statement that correctly interprets the confidence interval. The first one says that there's a 90% chance that the true value of the proportion will fall between the lower and upper bounds. So Triola has this issue about this phrase will fall, and this is definitely not what we want to choose. Will fall means that the proportion isn't already figured out and it'll land between those two things, but that's not the case. The population proportion already exists and we're trying to capture it with a confidence interval. The next one has a 90% confidence that the sample proportion is equal to the population proportion. We're all estimating here, so the idea of equal will not work for us either. So that's not good. C, one has a 90% confidence. We are 90% confident that the interval that we have actually does contain the true value of the proportion. That looks like it's a good candidate. And then the last one, 90% of the sample proportions will fall. Again, will fall is not a good phrase that we want to use. So we can say that we are 90% confident that the interval from the lower to upper bound actually does contain the true value of the mean. Alright, let's select that. It looks good. I hope that helps.